We shall now look at the ranges of some different functions. What is meant by range? From the fundamental definition, of course, if f from a to b is a function, then the set of all images, that is set of all f of x, is the range. That is of course conceptual directly from the definition. You see, the actual concept is very essentially be used while calculating some numerical problems, solving some numerical problems. So, let us have the basic thought in calculating some things. Look here, suppose f of x is equal to sin x. A well-known function. To define f of x equal to sin x, there are no restrictions for any real number you will be able to have. Okay, you have given a real number for x, say some 3. F of 3. What is f of 3? Sin 3. 3 means 3 radians. If I give you x is equal to 100, then f of 100 is sin 100. Sin 100, sin 3, sin 40, sin 45, sin 45 degrees, sin 45 radians, sin 60 degrees, etc. There are so many things. Here the input is x, output is sin x. If you think of the input, you are thinking of the domain. If you think of the output, that's nothing but the range. We all know, pretty well we know, that the values of sin x are always in the closed interval -1 to 1. For whatever real value of x you find sin x, you can never get a real number greater than 1, and you can never get a real number less than -1. This sin x, the value of sin x, always lies between -1 and 1. See, the output here is sin x. We are thinking of the output. As this is the output, this is the range. How far that sin x range? From -1 to 1 only it can move. Beyond that it cannot move. That is why range of sin x is closed interval -1 to 1. There is a range of f of x is closed interval -1 to 1. You could have well recollected the actual difference between the words range and domain. So like this, the range of sin x is closed interval -1 to 1. Now, let us observe standard ranges or ranges of some standard functions now. Let us recall some standard functions which we usually come across for many number of times. First thing, f of x is equal to x. What is the domain of this function? Real numbers. Domain of the real function is real numbers. How far does it range? Definition is also x. As and when as we give a particular input, the same output is going to obtain here. Therefore, range is by what symbol we are representing this range? RF is nothing but R. Take f of x is equal to mod x. What happens to the case? What is the domain of this function f of x equal to mod x? Set of real numbers. Why? Because for any real number we are able to have mod x. The input here, what real numbers you can give to this x to find f of x? Real numbers. So that is the domain. What is the output? Mod x. The nature of mod x you must be knowing. Mod x is always non-negative. It is either positive or at most 0, but it can never be negative. Hence, the range of mod x here is, what is the range here? closed interval 0 to infinity. Closed interval 0 to infinity. Closed interval 0 to infinity. Another, suppose f of x is equal to integral part of x. Some others, some students, some lecturers used to read it as step x. It is now and then called a step function. Why? Because if you draw the graph of this one, it looks like steps. That is why somehow some others, some lecturers used to say this, used to read this, used to pronounce this as a step function. Well, what is this actually? The greatest integer less than x, or integral part of x. What is the range actually? That very name itself indicates integral part, isn't it? Therefore, answer will always be an integer. Answer, that is the output, is always an integer. Suppose I give some 10.5 to x. What is the output? Integral part of 10.5, 10. I just give 7. Integral part of 7, 7. I give pi. What is pi actually? 3.14 and so on, so on, so etc. So, f integral part of that is 3. Whatever real number you give here, answer, that is integral part, is always an integer. Therefore, the range of this function is of course z. Is z, that is the set of all integers. Set of all integers. Well, just like that, f of x is equal to e power x, or 2 power x, or 3 power x, 4 power x, a power x whenever a is positive. We call it an exponential function. Well, what is the domain of this function? Previously we could have noted it is one of the most standard functions which have the real domain. The domain of this function is real numbers. That is, for any real value of x, we can find e power x. Okay, you are finding what is the output. We know and we believe that e power x is always positive or non-negative. Absolutely positive, strictly positive. Even if you give negative values to x, e power x is always positive. What is f of minus 2? E power minus 2. What is e power minus 2? 1 by e square. What is 1 by e square? Strictly positive. No question of getting 0 also. You cannot make e power x 0. Whatever value of x you can take, e power x cannot become 0. Therefore, the output here, the nature of the values of e power x is of course is nothing but open interval 0 to infinity, or this can again be written as r plus, that is the set of all positive real numbers. Okay, well, let us see some more such things. F of x is equal to log x to the base e. Log x to the base e. What happens to the face of that? What is the domain of this function? What precaution that you have to take to define f of x? You are supposed to see that x must be positive. Therefore, the domain is set of all positive real numbers. That is, the input that you can give or you can offer to this f of x is set of positive real numbers only. F of minus 2, meaningless. F of minus 3, meaningless. F of 0, meaningless. F of 3, log 3 to the base e is meaningful. Well, what is the fate of log x to the base e? Should it be positive always? Should it be negative? Can you say that it can never become 0? We can say nothing. You can say nothing. F of e, log e to the base e becomes 1. Log e to the base e becomes 1. f of 1 log 1 to the base e, 0. f of half log 1 minus log 2, negative. f of e square 2 log e square to the base e, 2. So you are able to have negative answers, you are able to have a 0 answer also. f of 1 is 0. You are able to have positive answers also. There is no restriction at all. According to the output, it can be negative, it can be 0, it can be positive. Hence, range of this function is R. Range of this function is R. You observe these two things. Range of e power x is R plus. Domain of log x is R plus. Domain of e power x is R. Range of log x is R. So, domain of this is range of this. Range of e power x is domain of log x. So, these two are functions of the form f from a to b and g from b to a. This is a special case. Special interest is the case for us to observe such functions. They happen in the case of inverse functions. Of course, inverse of log x to the base e is e power x. You can state inverse of e power x is log x to the base e. Inverse of 2 power x is log x to the base 2. Inverse of 3 power x is log x to the base 3. Inverse of log x to the base a is a power x. Inverse of log x to the base 5 is 5 power x. Like that, we can be in a position to declare, yes, in these particular domain and range, they are perfectly invertible. Notice that domain of e power x is range of log x. Domain of log x is range of e power x. That is why they are invertible, mutual inverses. Yes. Next, we shall now deal with one of the most standard models which is frequently asked in so many examinations. Let us observe the function x square plus 4y square plus 9z square minus 2xy minus 6yz minus 3zx. What is the range of this function? So many students try to express this in the form a square plus b square plus c square plus 2ab minus 2ab minus 2bc, like that. You observe one thing, 3 negative symbols are here. This lengthier expression cannot be expressed in that form. At most, you can be observing this in the form a square plus b square plus c square minus ab minus bc minus ca, that's all. Of course, it is correct. It can be done in this form. What is that? X square plus 2y whole square plus 3z whole square minus x into 2y minus 2y into 3z minus 3z into x. This c is in the form a square plus b square plus c square minus ab minus bc minus ca, with a is equal to x, with a is equal to x, b is equal to 2y, c is equal to 3z. We know that this is not a perfect square. It cannot be expressed as something whole square. But this is a sum of perfect squares. How? It's very simple. You know it from the fundamental algebra. This is half of a minus b whole square plus b minus c whole square plus c minus a whole square. Isn't it? It's an easy matter to discuss with that. A minus b whole square plus b minus c whole square plus c minus c whole square, half of that is just nothing but this. This is a perfect square, this is a perfect square, this is a perfect square. So this expression can never be negative. This can never be negative, as it is the sum of three perfect squares. At most it may become 0. When can it become 0? When a is equal to b is equal to c, then only it becomes 0. But here, what is a, what is b, what is c? X equal to 2y, x, 2y and 3z. Can't they be equal? We don't know. They may or may not. But what can we say about this? This is greater than or equal to 0 for all x, y and z. Any real numbers x, y and z you can take in this one. So we always have it is greater than or equal to 0. Hence the range can be estimated as closed interval 0 to infinity. It may be 0. We don't bother about it. When can it become 0? As and when a is equal to b is equal to c. It may happen or may not happen. We are not interested in that. The nature of the output, that's all. So it is either 0 or greater than 0. That is why it is always non-negative. It always lies in the interval 0 to infinity, closed interval 0 to infinity. Why? Because we are allowing 0 also. It may become 0 also. Yes, this is the necessary observation. This is the necessary concept that you must keep in mind while making an attack on this problem and problems of this kind. A beautiful model. Yes, we now take one more such model to have another concept. F of x is equal to 1 by 3 plus 4 sine 2x. What is the range of this expression? What is the range of this expression? Of course, in no time, within few seconds, you can be in a position to estimate this also. I shall give you a particular mechanism to face such type of questions. You please observe carefully. As and when a function of the form 1 by a plus or minus b cos cx, or even in the place of cos x you may be having sin x also, the answer is supposed to be 1 by a plus b to 1 by a minus b if a not equal to b. If a and b are different. Or otherwise, if a is equal to b, it becomes 1 by a plus b to infinity also. Keeping this in our mind, you will be able to have the answer directly. What is a plus b? 3 plus 4 is 7. That is, range can be estimated as 1 by 7 to a minus b. This must be a greater number. This must be a greater number. To imagine that, this must be a greater number. You call this 13. 13 minus 4 is 9. 1 by 17 to 1 by 9. You can be having directly. Or otherwise, what is the actual pattern to have the answer? Look here. We have minus 1 less than or equal to sine 2x less than or equal to 1. Any problem? Because the range of sine 2x, sine x, sine ax, whatever it might be, range is minus 1 to 1. Hence, it should lie between minus 1 and 1. Multiplying it with 4, what is going to happen? Minus 4 less than or equal to 4 sine 2x less is equal to 4. Again, let us add 13 on all the sides. 13 minus 4 less than or equal to 13 plus 4 sine 2x. 13 plus 4. That is, 13 minus 4 is 9. 9 less than or equal to this, less than or equal to 17. Let us have the reciprocals. 1 by 17 less than or equal to 1 by, this is nothing but f of x, less than or equal to 1 by 9. without putting these 2 or 3 steps, we will be able to have the answer by using the technique, of course. 1 by a plus b2, 1 by a minus b. As and when we come across such things, let us have the technique. It is that so-called technique has been designed by proceeding in this way only. You too can do that very simply of your own. Well, you can be in a position to get that. Yes. Now, let us turn our head towards observing another model. F of x is equal to a1x square plus b1x plus c1 by a2x square plus b2x plus c2. Like this it will be given. And you are supposed to have the range of f of x. Of course, this type of problems can be discussed in the chapter quadratic equations also. There also, find the range of so and so function, he will be asking us. As we are in functions, discussing the range of a function makes important here. That is why I am dealing with this problem in this connection, a1x square plus etc. Let me first of all give you a picture of the mechanism of or the procedure or the technique. Look here. Let me denote D1 discriminant of the numerator, D2 discriminant of the denominator. The actual procedure, we know that this is equal to some y. We will be getting a quadratic in y. After noting that quadratic only, we will be able to have the answer. Now, I shall help you in tracing that quadratic in y. How? Look here. D2 into y square plus 4 into a1c2 plus a2c1 minus 2b1b2. Of course, in the beginning you may feel that it is a tedious job, but if you apply this for 2 or 3 more problems, it will be very easy to follow. Into y plus d1 greater than or equal to 0. This is, of course, the mechanism that can be used to trace the range clearly. Let us have an application for that. F of x is equal to, you suppose, x square minus x plus 1 by x square plus x plus 1. What is the range of this expression? Let us try to use D2, discriminant of the denominator. What is that? B square. 1 minus 4 is minus 3 plus, what is D2? Discriminant of the denominator. B square is 1 minus 4 is minus 3 into y square plus 4 into a1c2 plus a2c1. Think of 1 into 1 plus 1 into 1. How much? 2. 4 into 2? 8 minus 2 into b1 b2. What is b1 b2? Minus 1 into y plus discriminant of the numerator. What is the discriminant of the numerator? B square minus 4 is again minus 3 greater than or equal to 0. So it is minus 2 into minus 1 is plus 2. A plus 2 is 10. Hence this takes the form 3y square minus 10y plus 3 less than or equal to 0. That is y minus 3 into 3y minus 1 less than or equal to 0. If you apply the sign technique for the roots 3 and 1 by 3, you can easily trace that y belongs to closed interval 1 by 3 to 3. What is this y? We generally suppose this to be some y. Y is just nothing but the nature of f of x, that is range of f of x. What is the range of f of x? Closed interval 1 by 3 to 3. So the concept that you must learn, that you must keep in mind is this one. Discriminant of the denominator into y square plus 4 into a1 c2 plus a2 c1. Sum of the cross products minus 2b1 b2 into y plus d1 greater than or equal to 0. Okay, how to believe this? Why is it necessary to believe this? It's very simple. I have taken this y, I have cross multiplied, I have got an expression connecting x squares as x is real, because these are all real functions, you see. So x must be real, and using the discriminant, it's nothing but this. This also, you will definitely be in a position to obtain this technique of your own. You please try, you can try. It's very simple. I have revealed the secret. What is the secret of obtaining this? I have taken this y, cross multiply. What are you going to have? a2x square plus b2yx plus c2y is equal to a1x square plus b1x plus c1. You gather all x squares, a2y minus a1 into x square plus b2y minus b1 into x plus c2y minus c1 is equal to 0. It is a big quadratic equation in x. It is supposed to have real values, real roots. Why? Because x is real. X is real. Hence, that discriminant is greater than or equal to 0. You expand the discriminant, you will be able to have this particular condition or the technique or the mechanism. Of course, this mechanism helps us a lot in simplifying the procedure. Some time will be saved. So some 10 to 15 seconds of time is definitely saved if you can follow this procedure. And that is a ready-made application. Yes, of course. From that, you will be able to have the range of the function. Well, let us observe one more such thing. Consider the function f of x is equal to x square by 1 plus x square. F of x is equal to x square by 1 plus x square. Of course, it's not impossible. Both numerator and denominator are quadratic expressions. You can be in a position to estimate the answer by using the previous mechanism also. Why not? Let us use it. This is nothing but 1x square plus 0x plus 0 by 1x square plus 0x plus 1. As usual, we suppose it to be some y. Come on, think of the previous mechanism. Discriminant of the denominator b square minus 4ac is nothing but minus 4. Am I right? B square minus 4ac plus a1 c2 plus a2 c1. What is that? 1. 1 into 1 plus 1 into 0. How much? 1. 4 ones are 4 minus 2 into b1 b2 0 into y plus discriminant of the numerator b square minus 4ac 0 is greater than or equal to 0. That is minus 4y square plus 4y greater than or equal to 0. That is 4y into y minus 1 less than or equal to 0. It does mean it belongs to closed interval 0 to 1. Closed interval 0 to 1 according to our technique. Yes, without using this technique, one more thing. This is a technique which helps us an idea, which helps us to get an idea. Well, look here. X square and 1 plus x square. Can they become equal? X square and 1 plus x square, can they become equal? What I mean to say is there any possibility to get this as 1? 1 plus x square is equal to x square. If at all it happens, then 1 is equal to 0. Foolish. Therefore, we repeat, it to be some closed interval 0 to 1. Without doing all these things, we will be able to do one more thing. Without going in this way, simply by looking at that, we are able to have the answer. How? Look here. X square, perfect square. It can never be negative. X square, non-negative. 1 plus x square, absolutely positive. This is either positive or 0. Why? Because when x is 0, this becomes 0. Therefore, this is 0 is possible. Definitely this is greater than 0. Moreover, this is a proper fraction. Numerator is less than denominator. Hence, it is definitely less than 1. Observe the numerator. It is x square. It is 1 plus x square. X square is less than 1 plus x square. Surely, this is less than 1. And we should think of, is there any possibility to that fraction to become 1? If at all it happens, x square may become equal to 1 plus x square. Is it possible? If x square is equal to 1 plus x square and x square can be cancelled, 1 is equal to 0 is a foolish item to look at or to say. So, this cannot become 1, or at most 1 it may become, that is interval 0 to 1, closed towards 0, open towards 1, or left closed, right open interval 0 to 1, we can say. Yes, like this we can estimate the answer. If I omit this x square in the function, now can you tell me that range? Can you tell me the range? Think of, numerator is 1. Consider the function f of x equal to 1 by 1 plus x square. Numerator is 1. Exactly positive. Denominator is also positive, 1 plus x square. X square is non-negative. 1 plus, that is strictly positive, no doubt. Positive number by positive number, positive number. Okay. So, it is always greater than 0. So, the range starts from this, like this. Again, you guess. Should we put closed bracket or open bracket towards this? If you use a closed bracket towards that, think of, is there any possibility for that expression to become 0? If 1 by 1 plus x square is 0, is it possible? It is just not possible. Therefore, the range starts from this. And again, what is the upper boundary? It is again a proper fraction. Numerator is 1, denominator is 1 plus x square. Surely 1 is less than 1 plus x square. So it must be less than 1. Again, think of. So upper boundary is 1. Are we supposed to use open bracket or closed bracket there? Is it open interval or closed interval? Again, think of. Is there any possibility that 1 by 1 plus x square becomes 1? Think of, 1 by 1 plus x square is equal to 1. So 1 plus x square is equal to 1. Leaving 1, x square is equal to 0. Then x is equal to 0. Yes, possible. It may become 1 when x is 0. Who told us? We could have imagined it. Yes, we have tested it. 1 by 1 plus x square, can it become 1? If at all 1 by 1 plus x square is 1, 1 is equal to 1 plus x square, cancelling 1, x square is equal to 0, x is 0, hence f of 0 is possible to become 1, hence what is the range of this expression? Like this. Observe these two functions. There is no any other mechanism except our thinking capacity about the nature of the function. Both the functions, this is a proper fraction, that is also a proper fraction. Here there is a possibility that f of x may become 1, here it is not possible at all. Therefore, the range is closed interval 0 to 1, left closed, right open. That is left open, right closed interval. Left open, right closed interval. A beautiful example, a beautiful comparison between the ranges.